with the acceptance of the continental drift theory and the discovery of the seafloor spreading event, we can now finally explain why the certain Earth processes occur. So why do volcanoes erupt? Why do earthquakes happen? And why does the continents move around? So all of that can be explained by the continental drift theory. So for example, here we are looking at a picture of the Pacific Ring of Fire. So you already know what the Pacific Ring of Fire is. It's several locations along the Pacific where you locate volcanoes, very active volcanoes, and earthquake phenomena often occur. And that's because of the existence of plate tectonics. So you will see dotted along the Pacific Ring of Fire are actually trenches. So I have discussed earlier that trenches are locations where old plates are moving towards back into the earth. But if you imagine that, you are like feeding more coal into the furnace. So you have pieces or plates moving downwards into the earth. So since you have large pieces of plates moving back into the earth where it's fiery hot, full of pressure, the world needs to release some of that pressure, and that's what causes the earthquakes and the volcanic eruptions. So the pressure coming from the constant push from towards the trenches of going back, plates going into the trenches back deep into the earth, powers the existence of volcanoes in the Pacific Ring of Fire. So now you know why the Pacific Ring of Fire exists. Okay, so just take a look here, specifically in the Philippine Trench. So here you can imagine that old plates are being pushed here, okay, powering the volcanoes in our country. In addition, you have other plates as well. Here, Marianas Trench, Sundro Trench, okay, and the Middle America Trench, completing the Pacific Ring of Fire. So that's just one example of how plates move. But there are three main types of how plates move. So we can categorize them as follows. So first, convergent. So when we say convergent, plates are moving towards one another. So the root word is converge. So to move towards one another. So plates are moving towards one another. So that's a really bad arrow. But yeah, it's moving towards one another. And sometimes there is the existence of the subduction plate. So when two plates meet, it's not always an equal clash against one another. One of them may move towards the earth. So especially when it comes to continental crust versus oceanic crust. So oceanic crust always plunges back into the earth because it's denser. So the continental crust is less dense, that's why it's higher than the oceanic crust. So usually, the oceanic crust is the subduction plate. So subduction plate is the one moving into the trench back into the earth. So convergent, when you say convergent, that usually happens in trenches. Yes, sorry about my sort of penmanship with the mouse. Okay, so next, divergent, moving away production of new plates in ocean trenches. So you have already seen this. One example is the movement of South America away from Africa. So they are separating because of the existence of a mid-ocean ridge. And then we have your lateral plate. So the lateral plate is also called strike slip, and they're also called a transform boundary. So all of those are just synonymous. So when we say lateral plate, they are just grinding against one another. They're not moving towards or away from one another. They're just moving side by side in opposite directions. Okay, so let's focus here on the top. here location. So you will see these two plates are moving in opposite directions, but not towards or away from one another. So we should classify that as lateral. Okay, so next item, we have two plates which are moving away from one another. So we should classify this as divergent. Okay, and then we have two plates which are moving towards one another, so that is convergent. And as you can see here, one of the plates are moving downwards, so that is the subduction plate. Okay, so let's apply that to the more realistic or more like 3D sort of drawing. So you will see here, obviously, a mid-ocean ridge is considered as a divergent plate boundary because it's where two plates are moving away from one another. Then, old plates rather, are subducted or moved into the earth in trenches. So because of that movement, it creates pressure and provides enough magma to power the existence of volcanoes. So as you can see here, the continental crust is full of volcanoes. Also here, you will see on this side, okay, there is another trench which created the hotspot, creating an island arc, similar to our discussion for Hawaii in the last module. Okay. And then you will also have here a transformed plate boundary. So meaning they're moving side by side. So this used to be one ocean ridge, but now it's like separated into two because they moved. Okay, so you have here a continental rift zone. So if you can recall, that's one of the terms we have introduced in the geomorphic process. So rift meaning they separate. So we have an example, the African Rift Valley in Kenya. So those are young divergent plate boundaries. So not enough to like separate the whole continent, but it did create some sort of opening between the two plates. Yeah. So that explains the whole diagram. Okay, so this is just another diagram. Again, mid-ocean ridge, okay, divergent, trenches, convergent, and this is your subduction, showing a subduction plate, and all of that is caused by the convection cells of magma, where there is a continuous cycle of hot and cold plates moving around in our asthenosphere. So cold plate moves downwards. Since it's cold, it moves closer to the inner core. Since it's now hotter than the other parts, it starts to move upwards. And whichever is caught in this location will erupt in the mid-ocean ridge. Okay, so I think you should already master that cycle by now. Okay, so just want to show you a quick extra. So 3 types of convergent boundaries. So the first one is ocean continent. So meaning there are 2 types of crusts. So we have your oceanic crust and continental crust. So the oceanic crust is denser than the continental crust. That's why when those two meet, it's always the oceanic which will move downwards because it's heavier, then the continental one will stay afloat. So the oceanic crust will move downwards into the trenches. Okay, so that will power the earthquakes and volcanoes, and then since there is pressure being exerted by the oceanic crust, it will also form like mountainous area in the continental arc, and that explains that phenomenon is what's happening to the Philippines. So the oceanic plate is pushing to the continental plate, which created the Philippines. We are still part of a continental arc since we are part of the Asian plate. Philippines is located at the Asian plate, the Eurasian plate, but our islands have been formed because of this interaction, the ocean to continent plates. Okay, so we also have ocean. So two oceanic plates interacting. One of them will still be subducted, however, and that usually creates hotspots, like what happened to Hawaii, and I believe the Galapagos Islands as well. Okay, and then number three, we have continent. So when two continental plates interact, they create mountain ranges like the Himalayas. Okay. So think the Indian plate is pushing to the rest of the Eurasian plate, which created these mountain ranges. Okay, so just another study showing how the Philippine Sea plate is moving. So as you can see, it's not moving straight towards the Philippines, it's actually moving upwards. So there has been proposals that actually the Philippines will move upwards toward Asia in the future after millions of years, of course, since our plates are moving quite slowly. So it's moving 8.3 centimeter per year by average, and aside from the Philippine Trench, where you can find the convergent boundaries, you can also find lateral boundaries here along our country. So I think we can predict that later on, after millions of years, our country will look very different since several forces are already acting on our country as it is. Okay, so not only the Philippines, of course, the same is true for the rest of the world. So you can see here, different plates are moving at different directions. So they're bumping and colliding with one another, and the world will definitely look different after several years. Okay, so the majority of the research shows that the plates move at the average rate of between approximately 0.6 centimeters per year to 10 centimeters per year. So it also depends on the size. So mostly if the plates are quite larger, they move slower, while the smaller plates, since they're small, they actually move faster. So for example, here, two of the major plates, the North Atlantic moves 1 centimeter per year, and the Pacific moves 4 centimeters per year. There. So it will be, if you could calculate, like after 100 years, you will have moved 100 centimeters already. After 1,000 years, you will have moved 1,000 centimeters already. So, okay. All right. So that's it actually. One last thing, by the way. So there has been still some debates if our plates will continue moving in the future. So currently, they have seen that the plates have moved slower in the past million years. So in the early times of the planet, the plate tectonics were very different because the mantle is way too hot since the Earth is early in its formation. That's why the mantle was way too hot, and so it allowed the formation of the supercontinents. So there were more than one supercontinent in the past. It's not just Pangaea, there were others. And because the mantle was very hot, it allowed the formation of the supercontinents. So there are still debates on where our plate tectonics are going to be, where the continents are going to be in the future, considering that the mantle is going to continuously cool down, so the plates may move slower, but we are looking at the millions of years in perspective. So in human time, I'm not sure if the human race will experience the supercontinent, because that's gonna take millions of years. So there are proposals that the plates will move back into a supercontinent. I will link a hypothetical video. So I will link a video which is showing the prediction from now up until the 250 million years in the future of what the Earth would look like. Okay, so that's all for our plate tectonics video. I hope that was very interesting for you as it was for me. If you have any questions, concerns, clarifications, please feel free to message me through Messenger or Microsoft Teams. That's all. Stay safe. Bye.